happens when I have two chords and they intersect each other in the middle of the circle. So I have two chords intersecting the middle of the circle, and I'm dealing with segments, so I'm dealing with lengths. This is everything we need to know about chords intersecting and their lengths. That this section of the chord times this section of the chord equals this section of the chord times this section of the chord. All right, the only hard part is you do need to know the whole section. So there might be parts in the homework that they give you part of the section, you have to figure out the rest of it. But that's as hard as we can make these. It is just little segment times this segment equals this segment times this segment, and that's what we have written down right here. Now, just knowing that gets you 3 out of 4 points, just being able to set it up. Everything else will be for your 4th point. So let's say I'm doing example 1 on the test. All right, I'm going to say, hey, this segment here, that's too big. Let's do it in red. I'm going to say this segment here, which is 54, times this section here, which is 48. Well, that's going to equal, what other colors have I got? Let's do green. We got this guy, which is K, times this guy, which is 36. Yeah, nice job, Fritz. And I could do that, and I pretty much get 3 out of 4 points. All right, because that's what I'm looking for is can you set it up? Can you set it up? So even if you're terrible at math and you can't solve it, get 3 out of 4 points as long as you studied this exact thing. Like I said, you get to the test and you haven't studied this, it's a really hard problem. All right, so now we just divide both sides by 36. And we're going to have K equals that 54 times 48 divided by 36. What was the answer to this one? Do you have a calculator? Yeah.
72.
That's 72. I was about to say that. Thought it was 70 something, but 72 sounds perfect. That equals 72. Yeah.
I just multiplied 54 times 48 and then 36 times K and then divided 2592 by 36, which is what 54 times 48 was.
Yeah, that's fine.
Is it okay if I write it out like that?
Mm-hmm. And more likely than not, I would probably I don't have a calculator up here, so I'll write out as much as I can. But normally I'd probably in my calculator do 54 times 48 and put that number there. I think that's what you're saying you did, right? Mm-hmm. Yeah, that's 100% fine. Same thing for the next one. It's just the two segments multiplied. So we can do 6 times 8. That's going to equal one segment of the chord is x times the other segment of the chord is 3x. Well, 6 times 8, that's 48. That equals 3x squared. Divide both sides by 3. And that's going to be 16 equals x squared. Take the square root of both sides. Realistically, our answers are negative and positive 4. Do I care about negative answers in geometry? No, because it's not going to work. I can't have a distance of negative 4. So we're just going to say my answer is x equals 4, and we're done. That's about as hard as I can make those. All right? But if you don't remember this rule, you're going to struggle. And you also have to be very careful that if I don't give you this full segment, you find this full segment. All right? And you'll see the example that we have in the homework. I think it's like problem 4 or 5 or something. But you'll see when you get to it that I don't give you the whole segment. All right, any questions about what happens if I have chords intersecting in the middle and their lengths? Okay, the next one is what happens if I have secant segments and they intersect outside of our circle? Well, they pretty much have to because they're secant segments. So secant hits twice, and they intersect on the outside. I want to put a little information down first, just so I can talk about the terminology. The first thing I'm going to do is I'm going to scribble in this full line. And I'm going to scribble in this full line here. These are called secant segments. But I'm going to affectionately call it the whole. That is that whole length. This is the whole length I care about. I care about from the back end to where they intersect. That is the whole. I'm going to call that the whole. The second part I'm going to care about is just this little segment that's outside of the circle. And that is going to be my external segment. And I might just write down EXT at times just to save time. So I have a whole and I have an external. There's only two things we need to know about those two things. Whole and external. Okay, so we have a whole and we have an external. So I'm going to read this to you and then I'm going to tell you what it means. If two secants intersect in the exterior of a circle, then the product of their measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. Memorize that. Every one of those words. I'm just kidding. I like pictures, and that's why we got pictures next to it. All they're saying is if I take this whole segment, see how I have A to C? And I multiply that by the external. It's the exact same thing as if I take this whole segment here times the external one. So an easier way to remember this one is I always just use this. I always say it's whole. It's that whole segment times our external is going to equal the whole of the other one times the external of the other one. So the only thing I care about are wholes and externals if I'm looking for lengths of secant lines. All right, we just need wholes and we need the external. Kelly, did you have a question?
No.
You sure? Okay. Because like I said, if you're confused on this stuff, now's the time to get it sorted out. All right, so our example 3, we have an example down here. I want to take the whole and multiply it by the segment. So we're going to take 8 and we're going to multiply it by x. Now, I want to talk to something about the other line. The book is going to try to trick you. I mean, their goal wasn't to trick you, it's just to make sure you understand what you're doing. The book, instead of giving you 12, is probably going to give you 8. All right, they're probably just going to give you an 8 and a 4. And your question is 8 the whole segment? So I don't even care that 8 is there. The first thing you're going to do when you have problems that look like this is do exactly what we had. You're going to draw that line and you're going to say that equals 12 because I need the whole. So we're going to use the whole, which is 12, times the external, which is 4. So once again, I'll probably write it again. We have whole, we have external, we have whole, and we have external. Whole times external, and we're good. All right, well, that's just 8x equals 48. And so we have x equals 6, and we are done. As long as you remembered whole and external. Does that make sense? Okay. Before I even read that whole thing to you, we're just going to use what we already know to solve this one. Well, hey, I have a secant line here, right? So if I did whole times external, I would have Jm. Let's just treat it the same way. We have whole, which would be Jm, times our external, which is going to be JL. That's still true. That's still true. It's still whole times our external. Can someone tell me what's the whole length of JK? Thank you. Almost just seems like you're just kidding. You said it so seriously though. You're like, JK, why are you asking me such a stupid question? So it's JK. My whole is just JK. What segment of JK is outside my circle? What would be my exterior? It would be JK again. So if my whole is JK, my exterior is JK. That means if I have a tangent, we just take the secant one, same thing, it's just JM times JL. That's going to equal the tangent line or segment squared. And that's all it says in here. It says exactly what I just said. That the tangent segment squared, and the other one is our whole times our exterior. All right, let's do that example. Okay, so I have 6, that's my tangent line. So either you can think whole times segment, which would be 6 times 6, or you could just think, well, that's tangent, so it's 6 squared, equals my whole, which is 9, times the exterior, which is x. Well, that gives me 36 equals 9x. And we're going to have x equals 4. X equals 4. Questions on that? I'm going to ask you, why did I stop? Don't you think I should have one that's, if I have 2 tangents? I have a tangent here, I got a tangent intersecting here. Shouldn't that be the third one? Pretend that one's tangent. Just pretend. Yeah. They're already congruent. They're already congruent. If this was 6, that would have to be 6. And it has to be true for the same reasons the other ones are true. It still follows that segment times whole. If I had segment times whole, it'd have to be 6 times 6 on one side, which would mean the other side would have to be 6 times 6 as well. So we don't need a third rule. We already have that one. What was that? Oh. So we already came up with that rule. If I have 2 tangent segments, they're congruent. These are just if I have a tangent and a secant, and if I have 2 secants, and if I have 2 chords. And when we put all 3 of these things together, it's called the power of a point theorem. I'm not asking you to memorize the theorem. I just think it's an important thing to see that really we're just dealing with points. What happens if I have a point in the middle of a circle? Well, if I have a point in the middle of a circle and I connect it, I know those lengths. I know those lengths because, and we're just going to put the same information down, because AP times PB, so the distance from A to the point times the distance from the point to B has to be the same as CP times PD. Same information. Yeah?
Could you do PC times PD?
PC times, yeah, absolutely. Yep, same length, right? If this is 4, that would be 4 as well. Yep, you'd be fine there. For the next one, if I have 2 secant lines, I'm going to use those letters. If you want to use A to B or something like that, you're fine. I'm going to say, well, it's going to be our whole, which is R, times our outside segment, which is S. That's going to equal the whole distance, which is T, and that's going to be times U. Well, if I have a tangent, well, our secant's going to be the same, it's still whole, so that's R times S. That's going to equal, well, it's still T times U, but if you look at U is equal to T, so we can rewrite this as R times S equals T times T, which we could go one step further and say R times S equals T squared. And I'd probably just jump down here. All right. It's just so in case you forget, you're like, oh, it's tangent. I just remember the secant ones. Still same thing. Whole times external, and you're good on these segment lengths. Questions about anything we did? Was anything earth-shattering, brand new, I can't figure that out stuff. No, and that was most of our stuff, right? It was just, hey, if I have an angle, I do half, and that's our central angle kind of thing. It's just stuff you have to memorize and you have to practice. Okay, so let's go ahead and get started on our homework and use any extra time we have tonight, because hopefully we're not overloaded with homework tonight on our first day back. Are we? Oh. Well, if you can find any spare time, just start looking over some of those old rules so you're not spending all of Wednesday night, you're not up till 1 in the morning trying to memorize all the stuff about a circle.